Welcome to our first virtual session for Earth Science. We are going to be going through a lesson on measurement today, which is not the most exciting of topics, but is something that you have a quiz that's due on September 19th. If you've already worked ahead in the class, you might have already taken this quiz, which is fine. I'm going to try to give you some more insight into measuring and its importance here, but we are going to, so many things open here. Okay, so we are going to start with a little description of our rules for virtual sessions. Cameras on, participate, and be respectful. So if your camera is on and you don't want to be seen necessarily, right, you can feel free to like tip your screen up, or tip your screen down, or sort of angle it so that it's only maybe like your shoulder that I see. I just want to make sure that you are there, because last year I did have some people log into the Zoom session and then just peace out, and they weren't actually physically there listening or responding. So make sure that you're there, for real, I can see you. Also make sure that you are participating. We're going to do a lot of participating in the chat. So you can feel free to type in the chat to participate, or you can also talk and unmute yourself if you'd like. And then be respectful, right? Make sure you're respecting other people's opinions. You're respecting me as I present some information here to you. So we're going to start off with a little warm-up question. Something that you guys did in a recent assignment. What is the difference between a theory and a law? So go ahead and jot your thoughts down on either a piece of paper or in a Google Doc, or somewhere on your computer. We're going to spend about a minute here just thinking about the difference between a theory and a law. All right, so would anyone like to share, either in the chat or by speaking, what a key difference between a theory and a law is? Awesome, thanks, Devin. Laws have been proved, and theory is an idea that you're trying to prove. Great. Yeah, so law basically means that no matter who tests it, we always get the same answer, right? So for example, the law of gravity, right? We all pretty much agree that gravity is happening. Theories have a lot of evidence, right? But there's other competing theories usually. There's multiple ideas about what could happen, and they both kind of explain what could happen. So when we talk about earth science specifically, and we're talking about the earth, and we're talking about these changes over time in the earth, we're going to encounter a lot of theories, because really we don't know exactly how the earth started, right? And it's really hard for us to go back and study these things in the past because no one was there really to record data. So we're going to see a lot of theories in this class. So what we're going to do today is we're going to define measurement, and we're going to describe methods to measure the mass and the volume of multiple objects. Again, this is straight from the measurement lesson in Canvas, which I believe is 0.004. And when we're done here, you should be able to take the quiz if you haven't already. So we are going to be using Cornell Notes for this class. So I want you to type a 1 in the chat if you're familiar with Cornell Notes, and a 2 if you're like, I have no idea what that is. Okay, so we got a mixture here. So if you're familiar with them, right, you might already have your own method of doing them, but just to describe here how this is going to work, we do have a template, which I will link in the chat. And you can take these notes digitally or on paper, right? That's totally up to you, whichever way makes more sense for you. And basically, it's just a way to organize your notes. So for the topic or objective, we are going to be putting measurement. And in a second, I'll tell you what our essential question is for this lesson. And then as we go through the lesson, I'm going to give you some hints about what questions you should be writing in the left side. And in the right side is where you're going to be putting your notes. So if you've never taken Cornell Notes or you're not familiar with them, this PowerPoint is going to be posted in modules at the end of this session. And there's a great video here by Mr. Ling that kind of goes through the process and what you should be doing. And then there's also a PowerPoint that I made for my AVID class with a step-by-step guide. And it also kind of goes into the background of why taking notes is so important. And so basically what you're going to want to do is do the best you can to take these Cornell Notes. And if you already have your own note-taking strategy, see if you can kind of adapt the Cornell Notes to fit your needs. I will be checking once a module for notes. And we'll talk a little bit more about that at the end. So our essential question is, give me one second. My dog is making a ton of noise. Hendrik. Stop. Okay, sorry about that, guys. I have wood floors, and you just hear his little nails going a million times, and it's very annoying and distracting. So our essential question is going to be, how can we measure the mass and volume of objects, right? Pretty basic concept, although sometimes it is hard to figure out what equipment we have in a science lab that we could actually use to help. So first of all, why do we want to measure? Which, by the way, sorry, this is my third virtual session of the day, so I'm a little like, ugh, in my brain right now. You're going to be wanting to write your essential question here. So how can we measure the mass and volume of objects? So why do we measure, right? So why measure is something that you're going to write in that left column. And then in the right column, you're going to kind of describe why we're measuring and ways to measure. So measuring allows us to quantify or assign numbers to physical objects, right? That's the definition or explanation that they provided in the lesson. You might also want to think about collecting data, right? Almost every single science experiment that you do or hear about or see involves data, right? And the way that you gather and collect that data is super important. You want to make sure that, first of all, you're doing it the easiest way. And second of all, that you're doing it in a way that other people will understand. So we have standard units of measurement in science, and they're usually not the same units that we use in America, right? So a lot of times we're using inches, feet, yards, right? And in science, we don't use that, right? In science, we're going to be using meters, kilograms, Celsius. And that's so we can have a universal language to discuss data, really, is what it's for. So there's a lot of different ways to measure, and you might even recognize some of these terms from math. We can measure circumference, right? We can measure volume. We can measure the quantity, so how many of something there are. We can measure the temperature, the mass, right? So some of these should sound familiar. And when you're designing experiments and thinking about designing experiments, it's very important to think about what you're going to measure or your dependent variable. What are you going to measure and how are you going to measure it? So physical properties are kind of related to this in the sense that measurement is an example of a physical property, right? Physical properties can be described or observed. So examples would be the color, the size, the shape, the mass, the density. These are things that aren't changing usually, right? Unless you cut it or something like that, then obviously the shape and size might change. But the mass could change as well if you're cutting or changing the amount. Density will never change, right? Some of these things can change, some of them won't. But physical properties are going to be incredibly important for earth science because a lot of the observations that we make about the earth are physical properties. We'll also get into some chemical property stuff as well. So just make sure that you understand what a physical property is and how measurement is an example of that. By the way, if I'm going too quickly for you, if you're trying to write something down or type something, right, I will post this PowerPoint so you can always go back to it when we're finished here and you could fill in anything that you missed or look through it again in case you had to take a break or something like that. So then we get into this very important concept here of mass versus weight. So I wrote some pretty short, quick definitions of these here, but mass is the amount of matter in something. Weight is the effect of gravity on mass. So actually gravity pulling down the mass, and that's going to be your weight. So I want to ask you guys some questions about this. Are mass and weight always the same? No, right? Why? Can someone give an example of a time possibly when they wouldn't be the same? Great. So the weight of a person on Earth and the moon are different, right? Your mass isn't different, but if you go to the moon, you weigh less, right? Which you're like, oh, wow, I weigh less, but really you still have the same mass, right? Now here's another one. What if somebody says, I lost 10 pounds? Did their mass or their weight change, or did both change? Let's assume they're on Earth, right? And they say, I lost 10 pounds. What is happening? Did the mass change? Did the weight change? Did both change? Only their weight or their weight and their mass. So this is great. So here's the thing. If the person lost 10 pounds and they're actually staying in the same place, let's say that, like, I live in Portland, I've been in Portland for a year and I lost 10 pounds. I probably did lose some mass, right? Some mass probably did come off. So I'm made of less matter at that point, so my weight is also less. However, if I go to a different city, like I go way up in the mountains, I'll actually weigh less. My matter or my mass didn't change necessarily, right? So that's kind of one of those tricky ones where it's like maybe both changed, but it's possible that only the weight changed and not the mass. So when we talk about weight, right, we're going to assume it's the same as mass because we're going to be doing all of our calculations in the same place. However, when we're talking about mass, right, that's much more important for communicating with other scientists because the weight of an object might not be the same where they are as it is for us. So when we say mass in our lab, we're also saying weight, right? But it might not be exactly the same for other places. That's pretty weird. If you ever go on any trips, you should weigh yourself and see like if there's any subtle differences because it's pretty interesting. Like altitude really does have an impact on that. So, excuse me. So we just did this. Our mass and weight always the same. We just kind of talked about that. No, they're not, right? Mass is consistent and weight can fluctuate. Mass can also change, right? If you physically take some matter away. Okay, so now we're going to talk about measurement. Some of this I think is a review for you guys and probably is not super revolutionary here in thinking, right? But this is a good introductory kind of, do you know how to do these things lesson. So we're going to come up with ways. We'll start with mass first. How can we measure the mass of a liquid, a sphere, and a wood block? So let's start with the mass of a liquid. If we have a liquid, how do you think we can take the mass of it? So if I wanted to measure the mass of this water in my cup, what would I need to do? Would I just take the whole cup and place it on a scale and say, oh, cool, my water weighs 200 grams. Yeah, right, except the only slight different thing I would need to do is I don't want to know the weight of the cup, right? With liquids, that's what, yes, good, Vanessa, weigh the cup separately, right? With liquids, that's the only difficult thing is that you can't just pour a liquid on a scale, right? You need a container. So you want to measure the container first. So I would just take an empty cup, place it on my scale, write down how much it weighs. Then I would put my liquid in, weigh the cup, and say, oh, okay, you know, subtract whatever the cup weighed, that's how much my liquid weighed. So there's a little subtraction element in there just because liquids you can't place directly on a scale. So what about the mass of a sphere? We just have, for example, a tennis ball. How would we take the mass of that? Could I just put this on a scale and record what it says? The answer is yes, right? This is the easiest one. Even though it might roll around a little bit, right? I might have to possibly use like a piece of paper or paper towel or something to keep it in place. For any object that's not a liquid, well, or a gas, right? A solid object, you could just weigh it or take the mass on either a triple beam balance, which we'll look at in a second, or a scale. Same with the wood block, right? If we have a wood block, we can just place it directly on the scale and read our mass from there. So those three are much easier. So we'll look at pictures in a moment here of kind of what that process looks like. Now, what about volume? So if we want to measure the volume of a liquid, How do we do that? Excellent, Jack. Put it in a graduated cylinder, right? So even though finding the mass of a liquid was annoying, finding the volume of a liquid is the easiest, because I'll show you in a second what a graduated cylinder looks like, right? But we can actually just read the amount of water or liquid in the graduated cylinder, and that's going to tell us the volume in milliliters. What about a sphere and a block? How can we find the volume of those? I'll give you a hint. Math. Right? We would do math here. There's formulas for this, right? There's a formula for a volume of a sphere. There's a formula for a volume of a block. But what if we have an irregularly shaped object? What if I want to find the volume of a clip that holds papers? Right? I can't really easily do math on this. I mean, there are some square shapes here, but I don't know how I would find the volume of these rings. Right? So finding the volume of irregular objects is where we get a little confused maybe, but there's an easy way to do it. So we'll come back to that in a second. Here is a triple beam balance, right, which is a way that we can measure mass in a lab. So you place your object on the tray here, and you have three different, I don't know what the word I'm looking for is here, like three different things that you can move so that you can end up getting tens, hundreds, and ones in terms of mass. And you have a 0 over here on the right side. Let me get my annotation thing out here. If I can get it to come up. Come on, come on, come on. There we go. We have a 0 here. And so basically, once you've put your object on, you're going to move these different masses until you get 0. And that's going to tell you exactly how much something weighs or how much mass it has. Right? This is kind of an old school method of weighing things, and it's tedious. Our first lab that we do, we will use one of these. A graduated cylinder is pictured here, which we just discussed, where there's actually markings on here that will tell you the volume in milliliters. So when you put water in, if it goes to 10, for example, you would say, oh, there's 10 milliliters of water in this graduated cylinder. And then the displacement that I was talking about, we can see here with this little dinosaur man. So when you want to measure the volume of something that's irregular, that you can't easily do a math formula for example, this dinosaur, right? You can actually just place it in water and you can measure how much it goes up. So if we're going to find the volume of this dinosaur, we're going to look here and see that it's at 4, 2, 4, 6, 8, about 4.8 is our starting amount of water, 4.8 milliliters, right? And then our ending amount of water, once we've placed the dinosaur in, is 5.246, is 5.6. So we can subtract, right, and find out that 1 milliliter, what am I saying? You guys do this math. My brain is not working right now. How much volume does the dinosaur have? .8. Excellent. Thank you, Vanessa. I almost said it was 1, which wouldn't even make sense. 0.8 milliliters would be the volume of our dinosaur. Right? So we could do this with any irregular shaped object, and it's going to give us a pretty good estimate, at least, of what the volume of something is. Whew. All right. So the last thing that I want to discuss here with measuring is this concept of error, and that there can be errors, and there's always error. So error is something that always exists, right? It's always there, even if you try to do everything as perfectly as possible. So there's measurement error, and there's natural error. So if we go back to looking at this graduated cylinder, right, with the dinosaur, there's an element of error here when you're reading the amount. You notice that I read at the bottom of the water, right? That's where you're supposed to read it. But if you read it at the top, you would be getting a different number, right? It also could be that if there's more lines on here, I might actually find out that it was 4.9, for example, or 4.82, something like that. So there can be more precise readings depending on what graduated cylinder you're using. There's also natural error, right? That just occurs all the time. So I want you guys to try something, or at least think about it. If you have a pen or pencil nearby, I want you to grab it. I want you to hold it up in the air, and you're going to drop it onto your desk 5 times in a row exactly the same way. And let me ask you this. Was it the same? Did you drop the pencil the same way every single time? No, right? It's impossible. Even if you had a ruler and you were going up to the same exact height every single time and dropping it, your pencil, every time that it gets touched or touches a table or touches anything, it actually loses atoms, right? So even one time after being dropped, your pencil isn't the same, right? You also can't control things like the air, right? Maybe there was a little bit of a breeze happening the second time you dropped it. That could impact, right? So the point here is that no matter how much precaution you take, there's always going to be error. It always exists. So when we measure, we want to try to use the most precise tools we can so that we can limit the amount of error, but we can never get rid of it. Exciting stuff right there. So that's the end of the lesson. So what you're going to do now on your Cornell notes is take a second, try to summarize the lesson in 20 words or less. And I actually have to grab my computer charger while you guys are summarizing that. So take a second here, look at all the stuff you just wrote down, all the stuff we went through. How can you summarize in 20 words or less? Okay, there we go. All right, so hopefully you were able to summarize, right? If you're still working on your summary, that's fine. You can keep working. Our exit slip for this virtual session is going to just be doing the measurement quiz. This is not due for you until the 19th, right? So feel free to wait and work on this next week if you'd like. Maybe you want to do it right now while it's fresh in your mind. But basically, I'm just going to take some time right now to just sort of describe how these virtual sessions are going to work and take questions from you guys about the class if you have any. So the first thing is that all of the information about virtual sessions and labs is going to be on the first page of the course here. Right, hopefully you guys already saw this, but some people, for some reason, are having a hard time locating it. Virtual sessions will be every Friday from 11 to 12. I'm not going to send out reminders because it's every week. They will not always be an hour long, right? We are going to, well, I'm glad you were able to join us, Haley. So we're not always going to have a lesson. So this week we did a lesson. Next week we're going to have more like an office hours type situation where I'm going to give you guys a question that you're going to answer and we're going to work through together. And then I'm going to take questions from you. So when you come to the sessions, always be thinking about if you have any questions. Your question could be a general question like, why do we have to do this? Or what is that? Or it could be a question like, I don't understand on this assignment what the second part is or what I'm supposed to do for question 1. Right? So bring your questions, because then if you have that question, I guarantee someone else has the same question. And that way we can go through it together. And then sometimes we'll do a full lesson. I'm going to try to do a lot of lessons from Canvas so that we're actually saving you time as we go through the virtual sessions, right? So like today, now you don't have to go through and look at that measurement lesson. You can just go straight to the quiz. We will have 2 labs. Our first one is going to be on October 20th at 11 a.m. So what's going to happen on those lab days is I will be at MIWA, and if you're able to come in, I encourage you to, so that you could do the lab in person. Otherwise, you'll log in virtually and you'll get to work on the lab virtually as much as possible. So we only have 2 labs. Those are going to be pretty big grades to complete those labs, so it's super important that you come to those sessions, definitely. If you're not going to be able to make it to a session because you have an appointment or you have something else going on at that time, just send me an email, let me know, and then that way you can make up the session by just watching it later, right? I record every session, so you're able to rewatch it or watch it later. Oh, thank you. Yeah, 11 a.m. is the time every week, and the labs will be at 11 a.m. as well. So, yeah, so that's that. And then otherwise, make sure you're looking at the collaboration projects so that you can start thinking about which one you want to do and start figuring that out, right? Other things I wanted to say about the course, there's a lot of assignments for this course, right? So make sure that you're staying on pace. And that's why attending these sessions is going to be really helpful, because if you do have a question, I can answer it right away and you can keep moving through the course. Can you have a partner for the collab? Yes, you should have a partner, right? Hopefully, if you constantly come to these virtual sessions, maybe you can even find a partner that way, right? Otherwise, we will have a discussion board where you can find a partner, and you can collaborate, of course, in person, or you could collaborate online, right? So there's a lot of ways to do that. Taken so many notes over the past week. Yeah, right? So this class has a lot of stuff in it. And so make sure that you are going through every single lesson, even if it doesn't have an assignment. Uh-oh, but I just clicked modules. I don't think there's too many in this class. I know some other classes have a ton of lessons that don't have assignments, which is frustrating. So let's see. Let me see if I can find an example. Okay, here we go. Here's an example. So oh no, that does have an assignment. Oh good, I think all of them have assignments. So that won't be a concern for you guys. But yeah, there's a lot of stuff. So make sure you're staying on pace, right? Or getting ahead. And that way, when we do these virtual sessions, they'll actually make sense to you because you're in the right place in the class. Okay, so now I'm going to open it up to you guys. Do you have any questions for me, like general questions about the class, specific questions about an assignment? This would be the great time to ask them. Oh, yeah, so Jack asked, what classroom will the lab be at? I don't really know my way around the school, so where will I go? Yeah, it's going to be in the science room, which is all the way in the back of the school. I think it's classroom 2 is what it's called. But you can also ask at the front desk and they'll be able to direct you. All right, any other questions?
In my other classes, we raise our hands, so I don't.
Yeah, go ahead. You can talk. Go ahead.
Okay. What did I miss? Just like what did I miss for the first?
Okay. Yeah, you missed almost all of it. I'm sorry about that. So I'm actually going to post. That's a great question, too. I'm going to be posting in the very bottom of modules. We're going to have a new module that I'm about to create right now called Virtual Sessions.
Okay.
And I will be uploading the PowerPoint and also the video recording.
All right. Was it kind of just like walking through everything?
It was going through the lesson called measurement. And
Oh, I think I did that actually.
Great. So you might want to just glance through, make sure that you got all that stuff written down, and you'll be good to go. Yeah.
All right.
So yeah, if you're working ahead, some of the virtual sessions might be things that you already did. But a good thing to do is to have your notes out and be looking at them and make sure that you got all the important stuff down.
Okay.
So, yeah, I'm going to upload the PowerPoint right now. I will record the video, I will upload the recorded video probably later this afternoon.
Okay.
Okay, so otherwise, I am going to end the session. If you think of any other questions that you have, or you have a specific question about an assignment, make sure you email me, right? I respond pretty quickly, and I'll be able to help you out on that. So thank you, everyone who was able to attend today, and I'll see you guys next week. Bye.